Okay, welcome to the June 17th, 2025 session of a TAPR-HamSCI technical session. My name is Dave, KV0S, and this week, let's see, I've been cleaning up the shack and organizing a few things, but and trying to get some of my various radios, seeing which ones work and don't work um, among all the spares that I have. So that's it. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thanks, Dave. Last Thursday, the Scranton team and a member of the NJIT team all met at Dr. Christine Zagzewski's house, KE2FDW, and we installed a ARC 888 and a ground magnetometer up at her place, and a DX Engineering active vertical. So we put one more personal space weather station on the air. The installation went very smoothly. We had probably about 8 people all together, and it was a kind of a well-oiled machine. We had some people that were digging holes, other people that were working on the IT parts of things. So that was very good. There are some things that we still have to clean up on the installation. For one thing, we don't have the remote access set up yet, so Rob is going to be working with Christine over the next couple of days on getting the remote access set up. We'll probably have to touch base with Bill Engelke on making sure everything's uploading to University of Alabama. And one thing we found out during today's telecon was there was some big RFI at 14 megahertz that I did not see when I was there on Thursday. But so that's a bit of a mystery that we have to resolve. But we need to get the remote access first, and we still have to put on some filters. But other than that, the Scranton NJIT team, we had our weekly 2:30 p.m. Eastern telecon today. So we're continuing to make progress on all of those sorts of things. And I guess that's pretty much it for this week. We will have next week. I will not be here because I'm going to the GEM CEDAR conference out in Des Moines, Iowa. So I'll be out next week. And back to Net.
Hey,
I forgot about
well, next on the list is Dave, KD0EAG. Go ahead, Dave.
Hello, everyone. I forgot about that Des Moines thing. I was thinking about going up to it, but I've mostly been doing printed circuit board layout and a little bit of magnetometer related things too, but not very much. That's pretty much all for me. That's been keeping me busy. So that's it. Back to y'all.
Okay, next on the list is Bill Engelke. Go ahead, Bill.
Well, thanks, Dave. Good evening to you. Good evening to the net. Worked with Nathaniel on putting together a sort of a specification on a new function for the personal space weather station network, which will allow science users to assign new channels that can be rolled out to ARCS 888 stations, Whisper Dean stations, the stations that are compatible with that, to create new channels and turn them on and off, and a variety of different things like that for special listening campaigns, or when something of special interest happens on the sun, that kind of thing. So that's been the activity for the past couple of days. Back to Net.
Very good. Next on the list is Clint, K7OEI. Go ahead, Clint.
You caught me off guard. Just barely got here. Don't have too much else. Don't have too much to add at the moment. Just going back and forth a bit on timing things, and we'll see how if that comes up tonight. Back to you.
Okay. Next on the list is Dave New, N5, sorry, N8 SBE. Go ahead.
Just remember, November 8th, a sideband engineer,
Okay.
or subacute bacterial endocarditis.
That's easy to remember.
Yeah, nothing new, too much going on here. We're getting ready for field day. And our club will be doing that at the local Ann Arbor airport in the soccer fields, which we've done for the last several years. Running the Class 4A station and a GOTA station. So if anybody's in the southeast area of Michigan and the Ann Arbor area, you're invited to come out and see us at field day. Other than that, nothing else going on. I'm just listening on the wall here. Go ahead.
Okay, very good. Next on the list, let's see, is Dave McGaw, N1 HAC. Go ahead.
Good evening, everyone. Not a whole lot going on except cleaning more than the shack, doing house cleaning this right now. Yeah, we're planning our regular field day. We do it at a local school's fields. And then we had some aurora, pretty good geomagnetic storm this past week. I did go out and got to see some faint rays briefly, but it was a short but intense storm. Back to net.
Okay. And next on the list is Jay Schwartz, WB8 SBI. Go ahead.
Yeah. Good evening, everybody. The only thing ham radio wise that is new here since last time is yesterday I went to the Monroe County Radio Association swap in Monroe, Michigan. And when you look on the map on Interstate 75, it's on the I-75 corridor, a few miles north of the Michigan-Ohio line. It was a nice way to spend a Sunday morning. Had a lot of eyeball QSOs and saw some people I hadn't seen in a long time. And there was actually some good Drake equipment there, some Heathkit, and some Collins gear there also. So it was a good way to spend a Sunday afternoon or a Sunday morning. Other than that, not a whole heck of a lot amateur radio wise here. So 7-3, take care, everybody. See you next time down the log. Oh, yeah, and field day, CQ contest. See y'all.
Okay. Let's see. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. So I have some big exciting news. So on Saturday, I wake up and I received an email from Paul Nicholson, and if, for those of you who don't know, Paul Nicholson is he wrote Vila Forex Tools. He also hosts Abilene.org and has been involved in VLF both personally and professionally and academically since at least 2008. And so Paul, to me, his receiver designs, his VLFRX tool software, all of his contributions, his analysis. To me, Paul is a rock star, and in this field, and the community owes a debt of gratitude to him. And in fact, without his contributions, I wouldn't be able to make the strides in VLF system as I am now. But anyway, so he emailed me um, asking if I would be interested in supporting the ILDN. The ILDN is the Indian Lightning Detection Network. It's run by about 10 universities in India, with the main university being TAPR University. And its intention, so what it does is it utilizes VLF systems, pretty much almost the same systems that, or almost the same as the system that we have running at Nathaniel's, pretty much exactly the same. VLFRX tool software and spheric processing utilities that send spheric information from about I think 10 receiver sites in India to a central server for processing. And I've talked about this in the past. So Paul is unable to provide the support that he has been in the capacity that he has been. So he asked me if I wanted to help, and that includes not only general support of the system, making it more usable, developing it, but also developing the next generation of ILDN VLF receivers. So just to put this into perspective, it was almost if I received a message from God, and God asked me to join heaven. That's how amazing this was. So I mean, it was, I was kind of speechless, and I still kind of can't believe it. But anyway, so he felt, since I knew VLFRX tools and Linux and VLF receivers and properly citing VLF receivers, I've been doing this for so long, that I'd be a good choice. And the PI at TAPR University, I don't yet know how to pronounce his name, but he has saw my presentations on YouTube, and Paul said that he was quite impressed. So I am just reeling from this. So what this means? This means that that not only I could support ILDN and be a member of the core team, which is what Paul said, that I would be a member of ILDN's core team, and help develop the next generation of receivers. So the work that I do with this, I can also do the same work that I do with HamSCI and Nathaniel. And this could mean newer, better versions of VLF receivers, and the making the HamSCI Lightning Location Network more and more of a reality. So this is tremendously huge, and I can't wait to get more involved. I'm going to meet with Paul and the PI over Google Meet soon, and then we will get to work. So that was kind of the big news, and I just want to show just a quick a quick progress that I've been making with the VLF preamp in KiCad. So what I did was I connected all of the traces, verified them with the schematic, ran all the checks, and I also did keep out zones as well. I have to do a keep out zone for the other side. So it's actually coming together, you could see here, I wanted to definitely credit Paul. I put the name of the board, and then I put my information here. So this is just about ready. I just gotta I just have to do the finishing touches, and I also want to give one of these to Michael Howen. This way he could easily assemble it, build it, and get another VLF system running. So that is definitely moving along, and I'm happy with how it has turned out. That's all I have. Back to the net.
Well, very good, and congratulations, Nathaniel or Johnson. Next on the list is Paul Elliott. Go ahead, Paul.
Yeah, hi, everybody. First of all, can you hear me?
Yes.
Okay, great, thanks. Yes, sorry I missed last week's meeting. Sounded like it was pretty interesting, except for the part, Clint, you commenting about my losing my hair even more. I take that rather personally here, so watch it. Jonathan, I've got, see, we see this here. This is the Whistler Catcher GNSS interface box. This is what's inside. When I apply power, smoke does not come up. All the parts fit mostly. They fit well enough. Next spin, I'm going to shift this connector back like a 0.5 millimeter or something, but it fits. I am still waiting for the GNSS, those $90 parts that I understood were going to be coming from you guys. But there is testing. I just got these this afternoon, and I put the connectors on and powered it up. But I can do some testing, but not much until I get those GNSS parts. So anyway, good progress here. I'm quite happy with it. Everything pretty much fits, which when I'm doing new connectors and footprints and all that, you never know how I'm going to screw it up. But this time looks like everything came together nicely. The other thing I'm in Friday Harbor now. I just got up here Thursday morning at like 5 a.m. after driving straight up. But there was some stuff waiting for me. This is a Clint, we talked about this a couple weeks ago. This is a combination 30/60 megahertz low pass filter with shelf, and you can disable the 30 megahertz portion, you can disable the shelf portion, and I'm pretty happy with it actually. I was concerned it's a little bit squishy at the high end at 30 megahertz, but it's not too bad. So I think it'll be useful for what we were talking about. And I am really interested in following through on our discussion about the pulse per second timing. I've got some thoughts, given schedule and the number of unknowns yet. I'm unless somebody convinces me otherwise, I would recommend a modular, kind of a modular approach to this. But this is something, we've had some offline email discussions. Many of you have been involved with those, and that's probably as good a way as any right now, unless we wanted to spin off and have a meeting just about that. So those are the kind of 3 hot topics. And I've got other boards that came in that I've been out, some people might want to buy, but I was out of stock. So I'll be back in stock on those as well. So that's good. So back to net.
Okay, very good. Next on the list is Phil, K9Q. Go ahead, Phil.
Hey guys, let's see what's going on. Besides hacking K9Q, getting ready to leave town. I'll be going to Friedrichshafen next week, but in the meantime, we're going to a family reunion in Wyoming, so we're not kind of home between those 2 trips. allow a few extra days to try to resync over there and see some of the sites. I love the Deutsches Museum in Munich. That's where we'll be before Friedrichshafen. Other than that, that's about it.
Okay. Next
Quick
on the
message for
list.
Phil Karn.
Oh,
Just
yeah.
Phil, check your chat.
I'm doing that right now.
Thank you.
Okay.
Next on the list is, let's go Scott Newell, N5TNL. Go ahead.
Hey, Jonathan missed it, but SAQ will be transmitting on July 2nd. If anyone's interested. If anyone's got a connection, the WWV Club website certificate has expired, so you might want to let them know. Mauser has a little bit of stock on the FX10 and 20 dev board, so if you wanted one, now's your chance. And thanks to Clint, Paul, Phil, and Rob, I made real good progress on the BPSK Edge Detection and Timing Recovery project. So that's it for me. Thanks.
Very good. Next on the list is Tom, N5EG. Go ahead, Tom.
Oh, good evening, Dave, and everybody in the group. Been busy working on cost reduction on a 4-channel unit. And one of the side effects is we'll lose the ability to put in digital pulse per second marking in the data stream. And so the discussion everyone was having last week and this week on other ways to put in pulse per second marking would be of great interest for that project. So if I can get a pointer to the mails or discussion, that would be helpful. I'll probably just sit back and lurk, but the information would be interesting. It'd be nice perhaps if we could all do it the same way. Back to the group.
Okay, very good.
And
Well,
Tom, I just sent you the information you asked for.
Oh, awesome. Thank you, Nathaniel.
You're welcome.
and next on the list is Rob. Robinette, go ahead.
Yeah, hi. I've been, I think mostly the biggest change in the last week is, well, Glenn Elmore just deployed a Whisper Demon Grape system up on the ridge top above WWV. And in the process, he studied the power consumption because it's a solar powered site. And we realized that I hadn't really studied it, but but we don't need to run the mini PCs, but B-Links don't need to run at their full clock speed, and they are run at that speed primarily because the primary market are gamers, and uh, they the marketing department probably says we want to run these things as fast as possible, so the gamers are happy with them. But for our application, that high speed is really unnecessary. And Glenn found that he was able to reduce the total power consumption from about, I think, close to 30 watts down to 17 watts. That is a ARC 888 plus a B-Link together. So there, that system is running now on the mountaintop. It's not yet accessible. We're waiting for the Colorado State IT department to do their WireGuard thing. But we have dramatically reduced the power consumption, and at the same time, almost certainly dramatically increased the life of the CPU and the associated by reducing the heat. The B-Link's CPUs are running in the 70, 80 C range, um, even even at idle, some of the newer ones. And I hadn't really appreciated that, but with Glenn's investigations, I'm actually we're going to put that in kind of CPU speed control, and I think that'll dramatically decrease the power consumption. The system runs well at 12 volts. So I think we really have achieved a significant improvement and addressed, I think, one of the problems that we'd seen. One of our concerns had been the CPU heat. So that led to a period of hesitation last week, Nathaniel, where I said, wait a second. Well, we figured it out in a couple of days that we can solve that heat problem. So
That's the major thing that I was working on.
So does your recommendation for the computer remain the same then?
Yes, it's a B-Link 5825. I just received this afternoon 3 of them. They cost $277. As always, you need to poke around the Amazon site to find the best price. Even the B-Link store sells them at somewhat slightly different prices. So I have a link up, I think, on that I shared with people that to the Amazon, my Amazon wish list that points at the $277 priced B-Link.
Okay.
So I just received 3 of them that I'm going to use deploy out at KFS to upgrade KFS so that we have we get rid of the old computers. So that's a major activity. Tweaking up a bunch of other things. I'm trying to get fully compliant with Phil's latest FT8 and FT4 implementation, decoder and uploaders. And so I think that's in place. I've got one more thing to do to be compatible with your config files, and I think we will be able to run in a happy compatibility mode at the sites where Phil is working on his code and I'm working on Whisper Daemon. So
the 5825 for $277.
277, yeah.
Yep, with 500 gig hard SSD and okay.
Yeah.
And 16 gigs of RAM.
Yeah, that's more than enough for everything we do.
All right.
Or could hope to do even I think in the future. So, although and by the way, I think I have we've also incorporated the latest WSJTX 2.7 includes the new version of the JT9 decoder utility, which is the one that supports the MSK 144 decoding mode. And we went through a few gyrations on that and have that new version, 2.7 version is now incorporated into Whisper Daemon. So with that in place, now I have the decoder and I will code that mode into Whisper Daemon in the next, probably be a couple of weeks. I mean, I think that the goal here is, I think there's the major meteor events that QSO party is happening in August.
Mm-hmm.
So it'll be part of all the Whisper Daemon Grapes systems.
Great.
Will be running that way by then.
And that August Meteor Scatter QSO party, I do not think will be the last. There's already one scheduled for December too. So
it's the kind of thing where once it's like everything else, it'll just be on all the time.
That'll be great.
So it's not something you need. I don't think if it is as efficient as JT9 is at decoding FSK, FT8, and so on. It's almost no CPU cycles.
What I did learn though, so I should say one other thing we did last week was we talked with Rob Suggs, and then for NT, I think. He is retired from NASA Marshall Space Flight Center. I actually met him for the first time when Bill Engelke had us down in Alabama for the HamSCI workshop. Rob is a retired head of the NASA Meteor Environment Office, and he's a big meteor scatter guy. And so he's been working with us on defining the scientific objectives of the Meteor Scatter QSO party. And from talking with him last week, I think what we're really going to need isn't just the MSK 144D codes, but we are going to need the IQ or the wave files as well, because one of the important keys for knowing that you're actually getting meteor scatter and not something else is actually looking at the duration of the scatter and the communications and all that stuff. So I think there'll be continued discussions work on this, and this is part of why this is one of the motivating factors, not the only one, but one of the motivating factors where went to Bill Engelke and said we need to create this system for saying we're going to request recordings for certain amounts of time. So this is all
Okay.
different pieces.
It's the IQ. Well, it's interesting because you'd want IQ recordings, but the JT9 wants upper sideband audio,
Well,
1400.
I mean, the
So
thing is, if you have an IQ recording, you can get anything else.
yeah, it's just that if I don't record any of the other signals that are processed by JT9, they are all being recorded as upper sideband.
Okay.
So it's not, we could just create a IQ recording at the same time.
Yeah.
Or it is pretty easy to do a
the
conversion from IQ.
the reason I say IQ is because we have a system already in place to save the Doppler shifts and send them up to Bill Engelke's server. So it'd be the exact same thing here. You just use the same code, same mechanism, record a channel, send it to Bill Engelke's server. Then it's time stamped. It's archived properly with all the correct metadata. We have it for all posterity, and then the researchers are able to get it. So that's why I say the IQ.
Okay. Well, it's just just good to know all the requirements. It's not a big deal. So logically it's a little different. I mean, it's kind of an enhanced version of WWV, and we don't decode WWV. We would just take the recordings and upload them.
Right.
Here we would also record and decode these. So it's really just more a question of data transfer. How much it costs. But if you're not recording everything, if the uploads are going to happen, well, something would need to trigger a decision to upload a recording. That would.
Yeah.
Yeah. It's okay. Well, whatever. We can work on that. That kind of stuff is relatively easy compared to some of the other things that have to be done. So we're still kind of offline on the Whisper Daemon servers. So only they're limping along. So I have to turn my attention over to the server soon and work on it for several weeks. So anyway, back to net. We can talk about other things. The timing thing is wonderful. I'm looking forward to timing, and I think Scott is working. We're trying to establish a mechanism where the recorder, PCM recorder, which records the Whisper files, the recordings would be triggered by this PPS signal that would be included, be present on the same multicast stream, I would hope, ideally. So we could get whatever microsecond level resolution start times, because right now our start times are consistent, but they're offset by tens of milliseconds. The recording starts tens of milliseconds before the tick, and anywhere from 15 to 60 milliseconds of samples are in each recording. So they start before the tick and they end before the tick because they're all exactly 1 minute long. So with the timing signal being present, hopefully PCM record could then start within with a few samples times of the actual tick time. So that will be a major improvement in our system in the temporal direction. Right now, we've established frequency accuracy, but we haven't yet established temporal accuracy. I mean, we have decent technical, temporal accuracy. Tens of milliseconds isn't bad, but I think we learned through you from Phil Erickson that the scientists want to have much better and need much better temporal accuracy than we currently have. So we have a path to it. It's just, and I think it's mostly in the hands of Paul and Scott at this point, and Phil to some extent. But I think it's mostly Paul and Scott. So they They haven't said much, but they're making they're working on a major enhancement to our system. So back to net. That's
Okay, well, I think we've called on everybody. So we basically are open for general discussion.
Paul, I wanted to give you an update on the shipping of those modules. Apparently the DigiKey shipments, we're having trouble locating it. It did get shipped to the university. It got delivered, but we're having trouble locating it. So I will be on campus on Thursday to try to find it. And then I will get those modules sent out to you as quick as possible. But yeah, that was the holdup
Yeah.
is that we can't locate the package. But that's kind of expected for a very large facility and with many buildings, mail rooms and routing of mail and things like that. So
I think Jonathan, if Salisa isn't sure, also check with Majid, because Majid gets a lot of the packages, and he might have picked it up.
I did check with him when I was there the previous Friday.
Okay.
And he didn't have it.
Okay.
I'm not sure like if no one's name was on it.
It says no, it's got my name on it. Well, no, that's a Siglin. Here, well, you keep talking. I'm looking through my email records now.
Yeah, I mean, I don't know if
it has your name on it. Well, does it?
Right. Yeah. I mean, I would hope that the package does. But perhaps, I don't know, there was some sort of mistake in the mailroom or something because it wasn't in the normal area where all of the packages were.
Yeah.
So
Okay.
and
No, I found the right invoice. It says shipped to Jonathan Rizzo. So yeah, and you know what? It may actually be in the mailroom because it says shipped to Jonathan Rizzo and it doesn't say Department of Physics and Engineering on it, just says University of Scranton. So it's possible that because the label, the mailroom may just not recognize your name, so they might just be holding it. So
okay.
so you can call, have Salisa call the mailroom tomorrow and have them look for a package for Jonathan Rizzo.
Okay.
Yeah.
Perfect.
Okay. In the meantime, I do have some boards, previous prototypes of mine with, a different but, close enough for now GPS chip on it, and on this new board here, I've got test points, and I've got test points on my old board, so I can run jumper wires between the two, and just at least do some realistic testing with it. I could probably, if I can get the software up and running. I do have one of the USB audio, the Behringer boxes here now, so I can start playing with it. It's one of many things I'm working on, but if I need to, I can do some testing with what I've got here now. Oh, and also, Nathaniel, as far as the Whispersons, I've got 13 of them here, and I've got 7 of the filter combiners, and I've got 3 more that are all soldered and just need to be tuned up and put in a box. So just a few days, I should be able to ship out that order, the 10 total Whisperson systems.
That sounds great. Thank you.
And let's see, one more thing on the GNSS interface box. It's been over a week since I asked last time, and still no activity on the payment from the university for this. I mean, I used the money I got for the Whisperson sale towards buying these parts, but sooner or later, I hope to see something from the university.
You should. Did Salisa give you any information on that?
I have not talked with her. I was told it would take maybe a week.
Yeah. So if it's
I
taking
mean,
longer
I
than
can call. I can talk to her. I mean, send her email. I'm fine with that. If you think that would help.
Well, Salisa will be able to figure out where it is in the process.
Okay. No, I've got no problem with that.
Yeah.
With any of that. I just
Paul, my experience has been it's through 2, 3, 4 weeks before it does an ACH transfers.
As long as I know it just didn't fall on the floor and was lost forever, I'm happy with any kind of reasonable delay. That's not a problem.
Yeah, so Salisa can figure out where it is in the process because
okay, I'll drop her a note
through multiple offices and things.
Okay. So so where do we stand on the timing synchronization that Clint and Scott and I and others have been working on? Well, how should we move ahead on that?
Okay, so I started reading through the emails today. I was away camping with my son this weekend.
Good.
Thank you. It was a lot of fun. But yeah, I started reading through the emails today, so it looks like you have some good ideas. I guess, what kind of direction do you need at this point?
Well, I need to know, what it is we want, because I'm not familiar with kind of the end user part of the system really, and certainly I'm not familiar with the software end at the receiver. I don't want to propose something that's just ridiculously hard, at the receive end to process. My thoughts right now are based on what I do know. Is it sounds like just sending BPSK modulation of some carrier frequency to be determined, but probably above the Nyquist rate, and that would alias back down to somewhere, where that the receiver could receive it.
Mm-hmm.
And just every second, once a second, the phase would reverse, and that's ridiculously easy to do. Suggestion was that we do that in hardware rather than in software. I can do it in software with 20 or possibly 10 microsecond accuracy, but if we do it in hardware, we can get sub microsecond accuracy easily. Why don't I'll put together kind of a proposal via email, just to throw a dart and just whatever metaphor you want to use, run a flag up and see up the pole and see what salutes it. But just to kind of force some decisions to be made, really.
Yeah.
But I think mainly because of how little I understand about the end system here, kind of a modular approach that lets us. Scott suggested, I think it was Scott, or asked about using the Bodner with a dual output. It's got PPS and it's got any frequency we want coming out of it. And that could drive a very simple box that would do the phase inversion on a 1 second basis. And then another box to do the injector and probably filter. And these are all simple things to do. The hard part is really going to be at the receive end. Not the transmit end is pretty trivial almost.
Right.
And these are designs that, I could get boards made, inside of two or 3 weeks, we'd have boards for these things. Or if somebody wanted to prototype with through-hole parts and wire, these are off-the-shelf parts. It's not that difficult.
Mm-hmm.
So that's kind of my I will write that up in email, send that out to the usual suspects. Nathaniel, if there's a larger group of people than the one that
I
has
think
been on
that
the
I
list
think
that
that
I've sent out to.
that list is good. Did you email? I think you should include John Ackerman.
Okay.
Have you been including him?
I don't think he was on that, but I will include him.
So anything with timing should include John Ackerman, and you can include Phil Erickson too.
Okay.
And I think one question was regarding like the accuracy. I mean, one way to think about this is every microsecond is 300 meters. So yeah.
And so what do we want? I mean, I can with the phase inversion, driven by the GPS PPS, honestly, we're talking, the PPS is, what's that, like, 50, 70 nanoseconds variability with the typical GPS. I could be wrong about that, but it's, easily 100 nanoseconds, which is, what, 10 meters?
Which I think would be much better.
But can the receiver, based on, the sampling, can that be resolved at the receiver? And that's something I don't know.
I don't know either.
The transmit side is easy on this. It really is. Once we decide what we want to do.
Right.
And yeah, can make it more or less elegant and faster, cheaper, you just pick any, whatever. But again, the transmit side, I think, is easy here, especially if we simplify it down to the modulation at a 1 second rate. And this approach that I'm suggesting, if it's like a multi-box approach, cheap small boxes, the modulating signal could be actually anything we wanted. So later on, I could try my spread spectrum stuff with that, and the same hardware is going to do that as well. But feeding in a 1 hertz pulse is, certainly easy. So anyway, I'll write that up. Phil Erickson and John Ackerman, assuming I can find those email addresses.
I can send them to you.
Yeah, if you would, that'd be great.
Great.
And Clint, I really want to hear your opinions on this stuff.
And actually, you can add Bill Lyles too. I'll send you.
Send me the full, who
Yeah.
you think should be in on this, and I appreciate any feedback, because I've got my perspective on this based on limited understanding.
Yeah.
And maybe what I think is easy just isn't going to be good enough for some reason. So I want to hear about that if I'm going to be part of it.
Yeah.
So several things come to mind. It'd be interesting to know the detection bandwidth used when they do the super darn detection. It would also be interesting to know on the bistatic radar that are using the wave profilers that has been discussed in the past, what bandwidth those are using, because the wave profilers themselves don't operate over more than 100 or so kilohertz bandwidth at most. So those kind of bracket, what the practical limits are. The real practical limit is you can only get so much. I mean, you will never get nanosecond accuracy on HF. There just ain't enough HF. And what is useful, and that needs to be carefully differentiated from what people would like to have.
Well, but what is useful? I mean, I hear things like, can you create basically a distributed like phased array system? So it's not so much that you're measuring the timing of the signal going from the transmitter to the receiver, but if you have a whole bunch of receivers distributed that are measuring the same signal, seeing the same signal, can you turn that into a phased array?
I mean, you're essentially talking about the equivalent of a VLBI on HF.
Yes, can you do that?
Well, here's a question for the VLBI folks. What do they use for their timing reference? I mean, I suspect they're using rubidium-based GPS references that have, sub-nanosecond uncertainty. And that is way beyond the pay grade of anything we'll ever be able to do.
Yeah,
And
the
it's
VLBI is using hydrogen masers.
okay, way beyond our pay grade.
So yeah, we can't do that.
No.
But we can do it, but not at that accuracy.
Right. I mean, what you're talking about potentially, I mean, I essentially, what you're trying to do is you're trying to disambiguate the massive multi-lobe monster that such interferometry generates, right?
Mm-hmm.
So, I mean, that would have to do with timing roughly equivalent to the period of the carrier or something close to that, right?
Yeah.
It'd be interesting to know. Well, Phil assures us that the K9Q radio is good enough to do that. I think. I noticed he's not here right now.
What did I say?
Oh, there you are.
I'm here.
Here's hypothetical. Assuming you had. Oh, okay. I looked for you earlier and I didn't see it. There you are. So here's a hypothetical. Supposing you had two RX-888s running from GPS referenced and somehow time synced. Would the acquisition in K9Q radio be able to be good enough to less than one cycle of phase at say 20 meters? I mean, would there be enough on?
It's totally deterministic except for one thing, and that is the timing of the FFT frame.
Okay.
Remember, I buffer up 20 milliseconds worth of data and then do an FFT, and that's a lot of samples. So the chances of two of them getting sampled exactly the same instant is negligible, right?
Right.
I mean, literally less than 1 in a million. So that would cause a timing or a phase shift in your output, timing shift in your output as well.
I mean, assuming you could identify that phase shift, would it be constant, more or less, as far as you know?
Well, once it starts, yeah, it will be constant, but it would change every time you restarted it or every time the RX-888 restarted.
Okay, I mean that's a given, of course.
Yeah.
Okay, so I guess the quick answer, Paul, is yes. I mean, if we could, I mean, if over a long period of time we could get some sub microsecond accuracy from our pulse generation at some high frequency, I guess that would work. I mean,
you're only going to see roughly 50 50 hertz, 20 millisecond accuracy, right? Because that's how long the blocks are, and it could be anywhere in the block.
Oh, that's true. Yeah.
Yeah, that's a way of looking at it. Or like I said, 1 in a million.
Right.
Because the FFT block size, well,
I'm
actually,
surprised. I'm surprised. I think we're talking about actual carrier phase differences rather than modulation phase differences. I mean, because that is a completely different animal when we're talking about phase resolution with the phased arrays.
Well, I'm just wondering how good it needs to be, though, because I mean, you are going to get a lot of scattering or randomization of delay from the ionosphere, but the question is how good is good enough? I mean, at least on VLBI and in astronomy, you probably have fairly well characterized timing, and you can you can estimate the delay in the ionosphere through the atmosphere of the signals arriving at your sites.
Yeah. And again, in a way, we're talking about two different problems here. I mean, what I'm talking about is the synchronization of the receiver with a local source. And then it's what can you do with that given the receive software processing capabilities, timing capabilities, and given the over-the-air signals that you're actually trying to do something with.
Actually, no, I'm not sure that I was right in what I just said, Clint. Because if the sample what you're looking for happens in the front of the block, then it'll come out in the front of the output block. If it comes out at the end of the input block, it'll come out at the end of the output block. So would the delay be the same? I don't know. I think about it.
Okay. I mean,
I think it's a constant delay for every sample.
I mean, well, right. From a practical standpoint, if it's consistent, if it's consistently inaccurate, as long as we can measure the inaccuracy.
Once it starts up, it'll be stable. That I can tell you, unless something gets lost because something's too slow or something malfunctions. But other than that, it should be stable.
Right, right. So, for example, I guess Nathaniel, the question for the researchers would be, if you could get WAV files that were matched to within a microsecond of each other, would that be useful?
Yeah, I think Phil Erickson would be the best person to answer that.
And that also, but if the answer is yes, that also brings a whole bunch of other questions together, like what kind of bandwidth, detection bandwidth are you talking about? How the hell do you get that much bigger data files from one place to another with presumably limited bandwidth of a lot of these receive sites? How much drive space will it need? I mean, it brings up a whole, that's why I was saying trying to isolate what would be good and useful versus what you would dream of getting.
Right.
Right. And there's a huge gulf.
I do think if Paul, if you could draw up some proposal that puts a real design down on the table and puts down some real numbers that you think are feasible, and if you send it to that group of people, I think we'll get useful feedback.
Okay, I'll do that. And yeah, I agree that at this point we've probably talked, and I'm good at vague hand waving, but let's try to get some specific ideas down here and see where we end up.
My whole point about using the hardware determining the transition of being, if we can over design the hardware to do this, but apply the KISS principle, then we can always throw away accuracy we don't actually need for the time being.
And yeah, and Clint, doing the hardware.
Yes.
I mean, this is stupidly simple hardware, actually.
My two Eclipse transmitters and receive full bandwidth IQ files contain these very signals we're talking about, both at the transmit end and at the receive end. The tricky part is that data's in there. I probably have time of flight information locked in these files for the whole eclipse period, but how do I get it out?
Yeah.
And that, it's, I mean, it kind of reminds me of the pictures of the, what was it, of the lunar probes that they sent crashing into the moon prior to Apollo, leading up to the Apollo program. In the past couple of years, they've gotten beautiful high definition images out of those 60s era probes that nobody could have dreamed of.
Yeah, my father-in-law worked on those probes. My wife,
Ranger probes. It took me a second to come up with the name.
Yeah, I think it was the Ranger. Yep. Yeah, my family had a bunch of those photographs. The
I think you're thinking of Lunar Orbiter, actually.
No, they a few of them they crashed into the
early ones.
That was Ranger. Yes.
A guy I know, Bob Legg, W6QYY, was heavily involved in those. I don't think he's still around, but yeah, he was. We spent some hours talking about those.
Yeah, well, we probably won't have to crash any of our receivers into anything. Let's hope.
But so, yeah, one thing I could do, I don't know if it'll help you, Nathaniel. Not Nathaniel. Scott. There we go. I had to look up, and it's possible I could scramble and do it. I could probably get something up near the Nyquist frequency on Utah SDR, if you had some preliminary software to look at stuff. I mean, and we're talking probably about maybe to get good timing accuracy, 768 or 1536, megabit plus sample rates.
I've
mean-
been testing at 16 kilohertz just because that's what the WWV stuff is. And, I see 24 hours where it didn't drift one sample.
Okay.
But that's at 16K. I ran a test at 100K and my pulse shaping was marginal on the edge detection because my naive method assumed that the edge would be faster than it is.
But
so I'm comfortable at 16K.
Well, I mean, other than the numbers being bigger, and maybe you're going to have to use bigger than 16-bit counters or 8-bit counters. If I were to throw together something on northern Utah that more closely resembled what we're talking about, would it be useful for you? Perhaps I could give you access
Yes.
to the server. Okay.
Or I could send you the program and you could run it. Yeah.
Okay. Yeah, we could figure out how to get we could figure out how you could get access to that server though.
Well, I'll share what you're doing so we don't duplicate other efforts or going cross directions.
All it would be a flip-flop thrown into a DVM fed by probably a Prog Rock 2 from QRP Labs, because those are sub ppm stable, and I can mark them wherever I want. And I can actually time it from a GPS DO that is this, so the 1 PPS will actually be probably much more consistent than than just a standalone GPS receiver. I think we have one on site. We used in the past. So,
Scott, I want to chat with you.
Okay.
IQ Webs and over.
Yeah, I'm there.
Thank you.
Yeah, guys, I gotta run, but yeah, yeah, let's just share notes. I'll put something together, but don't think I've got any special secret sauce here. So it's just get the conversation on try to firm things up a little bit. Definitely want to hear what you have in mind, Clint, and anyone else.
I think we're on the same thing. Yeah. And also, I wasn't planning to filter this as much to see if it affected anything, but I think you're right. Being 6 or 9 dB down, I mean, it would quickly. I mean, the clicks would quickly go disappear into the noise floor.
Yeah. If it's a 1 hertz modulation rate, it falls off into the noise pretty darn quickly.
Yeah,
so anyway, I'll put something
yeah.
together, and but please, and I got your email, Nathaniel. Thank you. So I'll include these guys on the list, and please, nobody be bashful. I certainly want to get all the good thoughts we can on this, because it's an interesting project for a number of reasons. Because once we get this going, I mean, there are a lot of different things we can do with it too.
Yeah.
Again, just time of flight, just this time accuracy. That's the other dimension that we haven't really been playing with, and actually, time is probably my favorite dimension because of the dynamic range, if you will, of time is so much. Anyway, I like working in the time domain. Okay, guys, I got to run, and
I have to run too, and I will not be here next week, so I will see you in 2 weeks.
Okay, well, but check your email. You'll see something from me before
I'll
then.
be checking it. Thank you.
Okay. Good night, guys.
Bye, everybody.
7-3.